We are going to continue our study of Science Chapter 5 today with Lesson 3, Waves. So by the end of the lesson, you should be able to do the following. Identify the parts of a wave, explain how parts of a wave relate to wave movement, describe how ocean waves form and move, and classify types of waves. You're going to come back and watch the study jam on waves and currents. So here we have parts of a wave. Let's start with wave height. Of course, that is how tall or how high the wave is. And you measure it from the trough to the crest. You can measure the wave length from crest to crest or from trough to trough. That's how long it is. The crest, of course, is the top of the wave, and the trough is the bottom of the wave. Most waves form as wind blows across the water's surface and transfers energy to the water. Remember, energy cannot be created or destroyed. It simply changes forms. So that is what is happening here. You're going from the energy in the wind blowing across the water surface, transferring it to the water, creating the wave. So as the energy moves through the water, so do the waves. But the water itself stays behind, rising and falling in circular movements. And when you watch this brain pop on waves, it will show you this, and that will become clearer to you. So please go back and watch the brain pop and do the quiz. Okay, we can measure this. Wave speed is equal to the wave length divided by the wave period. So we know that waves not only come in different sizes, they also travel at different speeds, and this is how we can calculate that movement. All right, so wave period, how do we determine this? This is the time between the passage of either two wave crests or troughs at a fixed point. So here we have wave A. The direction of the movement is to the right. Then we have wave B. Remember, we're moving this way. So the clock begins running as wave A passes the reef's peak. So we're measuring it from the crest. And then in this picture, the clock stops as wave B passes the reef's peak. And then the time shown on the clock is 5 seconds, and that represents the wave period. And we could have also measured this from trough to trough instead of crest to crest. It would be the same because it's fixed. What about deep water waves? How do deep water waves become shallow water waves? So this happens when they reach the depths of less than half of their wavelength. So if you've been to the beach, you may have noticed this. So notice the shore that's going into the beach. It keeps moving up. So this distance and displacement of this wave is getting shallower as you go. This is going to cause the wave to push up as it gets closer to the shoreline. And when that happens, then you start seeing the waves break. These are called breakers. And then near the surf or the shoreline, you have what is called the surf. That's when it all mixes in. So you've got the waves coming in and then pulling back out, and then coming in and pulling back out. And if you've ever stood at the seashore, you felt this because your feet will go down in the sand. And that's because of the movement of the waves. So deep water waves are waves that move in water deeper than 1/2 their wavelength. So once they reach that, you can see they start pushing up. That water volume has to go somewhere. And then when deep water waves begin to interact with the ocean floor, those waves are no longer deep water waves. They are called shallow water waves. This is the undertow that I was talking about. Head-on waves create an undertow. So you've got this massive amount of energy that's coming in and they're breaking, and then it's being pulled back out. So that is the undertow. That's why you feel your feet, if you've been to the beach, kind of sinking in the sand. So the movement of water forms a subsurface current that pulls objects out to sea. That is the undertow. You never ever want to get caught in an undertow. But if you do, always, first of all, don't panic. That's when most people drown in an undertow. But you want to swim not directly to the shore, but at an angle. You want to follow the longshore current, and it will eventually bring you back into shore. So again, if you get caught by the undertow, which I pray you never do, but if you do, don't panic, number one. And don't try to swim directly to shore. You're not going to be able to overcome the undertow. You want to figure out which way the current is flowing, and you want to travel with it and swim not straight to shore, but kind of at an angle toward the shore. So water currents that travel near or parallel to the shoreline are those longshore currents. They form when waves hit the shore at an angle. Longshore currents transport most of the sediment in beach environments. So they are what bring up the shells and things like that you find as you're walking along the beach. Okay, so what about open ocean waves? You're out in the middle of the ocean, no land anywhere. And you have whitecaps. So you can envision that. It's like the wave is forming and starting to break, and that's when you get a whitecap. Swells also form out in the open ocean. So again, the whitecaps, they're named because of how they look. White foaming waves with very steep crests that break in the open ocean before the waves get close to the shore. So you only see whitecaps when you're out in the middle of the ocean, or even on the lake if the wind is really bad. Rolling waves that move steadily across the ocean, they never come to that cap, are called swells. So now we're going to talk about specific types of waves. You're going to go back to the Brain Pop and you're going to watch the tsunami video and complete that quiz. Then you're going to come back here, watch this video clip by clicking on tsunamis, about tsunamis, and then you're going to watch part of the Japan earthquake and tsunami of 2011. Now this video is about 45 minutes long, so don't watch all of it. Just fast forward it and catch highlights of it. If you have time later, you can come back and watch the full thing, but you don't have time in class to do that. So once you go back and watch the Brain Pop in those clips, you'll understand tsunamis a little better. But they are waves that form when you have a large volume of ocean water that suddenly moved up or down. Most of the time, this is done or caused by underwater earthquakes. So you can see this huge displacement of land by this underwater earthquake. All of this volume of water has to go somewhere. So it rises up, and then as it gets closer and closer to shore, you've still got the same volume of water. So it just creates this massive wave called a tsunami that you can't outrun it. So you want to get to the highest place possible that you can if you're in an area and there's a tsunami warning. Also, something very strange happens with some tsunamis. If you're ever on the beach and all of the water goes away and you can see the bottom of the shore, You don't want to go out there and check that out. You want to run and get to the highest place possible because this energy is pulling the water out and then it's going to bring it all back in and then some. Another thing, the last thing we're going to talk about are storm surges. This would be in like a hurricane, a really bad storm. We'll talk more about that later in our next chapter. But storm surges are local rises in sea level near the shore that are caused by strong winds from a storm, such as a hurricane. Winds form a storm surge by blowing water into a pile, big old pile, underneath the storm. So as that storm moves on the shore, so does this giant mass of water called a storm surge beneath it. And in hurricanes, we'll learn more people die from the storm surge if they're on the coast than they do from the wind or the rain or flying debris or anything else that comes with a storm. So you need to be careful of storm surge. You're going to come back and watch a video clip on storm surge by clicking on this. And this is the end of lesson 5.3, which is also the end of chapter 5.